Hello there. Welcome to another problem session. Okay, today we have a little bit simple problems, but you have to kind of in the know to get it. Okay. Uh, so there are two questions which are somewhat related to each other. One I will do it completely, and the other one I'll just let it for you to practice and maybe complete the problem. Okay. So here is an A. In this problem, we're given magnetic. This is magnetic dipole. That sits over here, and along the direction of the dipole. So this will be like a south pole and north pole of the dipole. There are various points. At this point, at P1, magnetic field is that, which is 1 centimeter away from here. And P2, which is 1.5 centimeter away, we need to find what is the magnetic field. What is the B at P2? B at P1 is this. B at P2 would be that. What will that be? Basically, I'm a very tiny magnet, and I'm sitting at different places, and I want to know if the magnetic field is such and such here, what's the magnetic field over there? It's actually a good question, and maybe you can practice. Okay. The second one is I have it's one tiny magnet, but I have basically a whole bunch of tiny magnets. That's what a bar magnet will be, a tiny magnets lined up. And of course, I'm going to make it so thin that you can just line them up on the z-axis. It's idealized, so this is line them up along the this axis, and along that axis, from the North Pole onward, there is a distance d. Oh, there is a missing data. This is L. Okay, so the length of is L. So what is the magnetic field? What's the formula for BP? Okay, what's the formula for that? Can we get a formula for that? Okay, so that's these are two questions. Maybe you can practice it, and I will pause this video. Okay, to do A, what do we need to do? What we need to be able to get the ratio. So we're B at P2 over B at P1. So if I know this, if I know a formula for this, I will be done, right? So how do I get this formula for this? So if I knew, like over here, if I put a dipole, you put a dipole here, and at a distance, say x from here, I'm going to use the z from here, and I'll call this axis the z-axis. This whole axis we'll call z-axis, and I'm at a distance z from here. That's point P, and I have a dipole mu. What's gonna be B at P? Well, it turns out mu, we can replace this problem by this problem, z-axis. So that's P, and from center to here, this is Z, and this is current I. So this is suppose radius R, and so I times pi R square in here is equal to mu in there. This equal to that in there. So I solve this problem, and I look for this in the answer of B at P here, and we have the answer. Okay, so how do I solve this? Well, this problem can be solved using Biot-Savart law. and it's been done in another video. And if you want, you can go to my website over here and you can see the derivation. I'll just quote the answer here. So BP, so let's see z-axis. So right hand rule say it will be along the k hat direction, and we'll have mu 0 over 4 pi, and then have a 2 pi for the integral around this, and we can have r square over z absolute value q. Because if you say I wanted to extend this and hover some point z negative, the direction will still be the same. See, magnetic field come out, it's up there and up there. On the axis is the same direction, whether you're above the circle or below the circle, right? It's the same k hat direction. So this is a absolute value z cube. All right, you can see already here there's I here, and so this I and all of this is mu. That will be replaced by mu. So we have the answer. So B at P2, B at P is this will be the magnitude part, and this is the direction part. So just that's the B at P part. So mu 0, a non-dipole moment over 2 pi z cube. So that's the answer. So if I look at this and this is common, so they're going to cancel out. Common to P1 and P2. So this is going to be z at z1 cube over z2 cube, and those are the d's, and so z1 cube is once. I really don't need to do a z1 over change even units because they're in the same unit centimeters. So z1 is 1 and this is 1.5 centimeters cancelled out. Centimeter cancelled out very nicely, right? Very nicely it's got cancelled out. So this is going to be 2 cube over 3 cube is 8 over 27. So it's going to be considerably reduced. So B at P2 will be 8 over 27 times maybe if I were to 2 times 10 to the 6 Tesla. So this is 16 over 27 times 10 to the 6 Tesla. So a little bit if this was 30, that will be half, so this is a bit more than half. Okay. All right, so you can just use calculator and get that answer. Okay, now we want to do B. Okay, you probably have you can see this formula can be applied to solve for B. See if you can do it. Okay, so you can pause, and now that you know the formula for maybe one part of this little piece, and then you can try to set it up an integral. This will be an integral, and then you may be able to do the integral and get the final formula. Okay, hope you were able to make a lot of progress on that. Let's see how I'm going to do it. Okay, so here is a another diagram of this, and I can put a origin over here and up to L. I have a this magnet, right? And then over here D plus L and z-axis. So this is the point P. Now if I take a dz at z, So over here will be m mu d mu, a small amount of dipole that will be there will be m times dz. So that's gonna be and the z is all positive the way I've selected. So how much this is going to do at b here, db. So this little dipole will and we know the formula that gonna be, so this z will be the distance from here to here in the z-axis, right? So db and everything is in the k hat, so I'm gonna all the k hat, every one of them doing the k hat, so I'm gonna just suppress the direction, just do the db sub z. So db sub z, the z component, and other components are 0. db sub z is going to be whatever d mu is, mu 0 over 2 pi, whatever d mu is, and with the from here to here is going to be the z. If I press the origin here, that will be the, so the z will be d, so d plus l minus z, d plus l minus z, and that's going to be the cube. That's the answer. And this thing here, this z will integrate only on up to l, so this z will always be less than this, so we can just make this like that. Okay, and d mu will become m times dz. So I'm integrating over this variable, so this will be b up z will simply be mu naught m over 2 pi, and I'm going to go 0 to l. That's where my magnets lie, so that's the integration choice, right? It's coming from that where the mu's are located. So this is dz over d plus l minus z cube. Okay, so if I've got this integral, then I can change variables and then, you know, come to the final answer, right? Okay, hopefully you were able to do this integral. So let's see this, we call this guy a, and we say a minus z equals to, say, x equal to that, so dx equal to minus dz, and so in this mu naught mu over 2 pi, when z is 0, x is a, when z is l, is a minus l, which is just d, a minus l, just d, and so you have a dx minus dx, and this is x cube, and so this will be mu naught mu over 2 pi 1 over x squared, 2x squared. It's going to be x to the power, so x to the power minus 3 dx will just be x over minus 2 over minus 2, and this minus will kill that minus, and so it's going to be 2, and then it's going to be a to d, and so I have a mu naught mu over 4 pi 1 over d square, and so d square is minus 1 over a square, which is d plus l square. So that should be the answer. Okay, so this all right, now I have a request. If you haven't subscribed to this channel, please subscribe it, and if you like this kind of explanation, you know, clean and direct explanation, please hit a like button. Thank you for your support of this channel, and take care. Bye.